Let us see like what are the transmitter and receiver can be used for this Wi-Fi network or visible light communication or optical wireless communication system. We can utilize transmitter as the LED or laser lights, whereas the receiver will be photodiode, and the medium will be visible light. You can see that this is one way communication like transmitter to receiver. Visible light is the medium we are using. And if we want to do the bidirectional transmission and reception, then Wi-Fi network downlink and uplink can be done by using visible light, or uplink can be done by IR, visible light, or UV, because that depends upon the utilization or user friendly environment. According to that, user can utilize any of this lighting system. Similarly, if we talk about this optical camera communication is one of the example that array of LEDs we can utilize for the transmitter, and camera will be utilized for the reception. So that will be also one of the optical wireless communication. Going ahead with the free space optics, we can utilize the LEDs or laser diodes for the transmitter, and photodiode at the receiver. So building to building communication we can do by using this FSO. So going ahead with that, what are the means current Li-Fi devices available in the market? Pure Li-Fi is one of the known company which is developing the light-based systems. You can see that dongles are used for this light receptions, and LEDs for the transmitters, and OLED also one of the company who has developed already Li-Fi based tablet. Similarly, Philips has also developed a panel of LED for the transmitter, and receivers also are there with the photodiode and uplink downlink communication. Also, they have here transceiver like a combination of the LED and photodiode, and here also. Going ahead, that what we have done at our institute, we have developed this prototype, like which is right now working. This is the panel of LED, and this is the Li-Fi access point. Which access point has the photodiode as the receiver for the uplink communication, and inside this access point, we have the FPGA board which can do the modulation, demodulation, other signal processing, A to D conversion. Everything can be done inside these communication modules are available inside this access point. And at other end of at the user side, we are using dongle. Dongle is having the photodiode for the downlink communication reception, and IR LEDs for the uplink communication as a transmitter. Well, this is developed in-house, and going ahead, we have transferred this technology to the industry like Velmini. They are now developing this AP and dongle and selling to the users also. Now this device, whenever we developed, it was supporting up to 100 Mbps. Right now, this device again it is developed, and some of the components have improved. So this device is supporting up to 200 Mbps. If we replace the visible light with the IR, then it supports up to 300 to 400 Mbps. Let us see how can we improvise or increase the data rate based upon the designing. Whatever I have shown, I have told already that if we are replacing visible light with the IR, then we can increase the data rate. Similarly, the lens designing or the type of the LED, whatever we are using, that can also improve the data rate. Based upon the your use of these different kinds of LED, we can also able to increase the data rate from 0.1 Gbps to the 1000 Gbps. And this all the research has been already done and published also. But like blue LED, it supports up to 7.6 Gbps already, article is available online. We can also look into that. That depends upon that which kind of lenses we are using, what is the demand of the user, how much we need to provide the data rate, according to that we can design this. Here the challenge is the designing only. Whenever we have the availability of the spectrum, the task is that right now we have to design the devices to utilize those spectrums. Now the industry has the limitation, means like facing for this designing aspect, because less industries are available in the market. Therefore industry should come forward and take the designing aspect, that how to improvise this data rate and utilize the availability of the visible light spectrum or IR spectrum for the optical wireless communication. Going ahead, we have the example of Li-Fi indoor communication. These are the future networks, like office environments. We can see in the left side and right side, we have the different office environments. Some people are sitting, some people are moving. So those users can utilize the LEDs installed on the ceiling for their communications, even though they are mobile. This switching technique can be also utilized. So these are the future networks what researchers are hoping to see in the future. If we see the Li-Fi networking, definitely, if we have the multiple Li-Fi access point or LEDs installed, those should be communicate with each other. So central network is required, and the backhaul network is required for them also to communicate with each other, and how much data rate should be allocated to each user. Those kind of networking is required, and it is already we have also done, and we have experimented also. It is working very nicely, and I will show in the future next slides also the demonstration. Here, whenever the user is also moving, they can switch from one LED to another LED or access point, so handover can be done also. And there is whenever the mobility is there, there may be the chance of interference. How to utilize this interference, mitigate this interference by rotating the LEDs, or the orientation of this LEDs can also mitigate the issue of this mobility. So many researchers have done this kind of research in this field also, and it's also working perfect. Let's see for the demonstration next slides. So we can see that how does this Li-Fi network work. So we can see here server is there, and if we need to provide the internet to the client side, from server to the client, whenever the packets will be transmitted, here the LED will be it means like light up based upon the lamp driver. Definitely the minimum voltage whatever it is required to transmit the data, whenever it reaches, then it turns on the lamp, and these packets will be converted to the electrical signal. Again, electrical signal converted to the light signal. Light will fall on the photodetector, and the photodetector definitely will be here. Again, some uh, processors are there, like signal processing will be done. Again, the converter, this light signal to electrical signal, then converting to the digital form, A to D converter. Then finally we can receive the packets at the receiver. This way we can do the Li-Fi networking. As we know that a basic communication system requires that input source, whatever we are utilizing in the terms of bits, then channel encoding, line encoding, modulation. Similarly, at the receiver side, demodulation, line decoder, channel decoder we need. And here, transmitter and receiver we are using, and RF channel we are using in case of basic communication, wireless communication system. What is the difference between the basic wireless communication system and this optical wireless communication system like Li-Fi network uses? Only this section we can see here. Transmitter is RF transmitter is replaced by LED or laser diodes. RF receiver is replaced by photodiode. RF channel is replaced by the optical channel like visible light channel or IR channel we can utilize. This is the difference based upon the RF communication system and the light communication system. These are the next generation network, whatever we are hoping for AR, VR applications. If we have auditorium like this, then we can also utilize the camera communication as well as light communication by utilizing this Wi-Fi network. School, offices, indoor, like classrooms, also smart classroom, they can also utilize the Wi-Fi network. Malls and some exhibition, indoor exhibition, everywhere we can utilize this kind of means Wi-Fi network or optical wireless communications.